Hey everyone, so today we're on the last section of chapter 12 and it is on the binomial theorem, and we're looking at Pascal's triangle and using that to expand terms without having to do FOIL and distributing and keep multiplying out and expanding. So here's how you create Pascal's triangle. So on the outside, you always have the ones. The ones are on the edges, the outsides. How you get the numbers in the middle is you take the two that are next to each other on the row above and add them. So 1 plus 1 is 2. Right here, 2 plus 1 is 3. 2 plus 1 is 3. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. Again, 4 plus 1 is 5. 6 plus 4 is 10. 4 plus 6 is 10. 1 plus 4 is 5. Let's go ahead and just do the next row as an example. So 1's on the outside. 1 plus 5 is 6. 5 plus 10 is 15. 10 plus 10 is 20. 10 plus 5 is 15. 5 plus 1 is 6. So that's what your next row would be. And I'm going to move these a little bit higher. So 6 and 15. Okay. So we're going to use this for the first example and for this whole section. So use Pascal's triangle to expand x plus 2 to the 5th power. So how you do this is you start with your first number and you raise it to the highest power, which would be 5. And then you start with the second one and have it to the lowest power, which is 0. And then you decrease or increase. So let's do this as an example, and we can get through how we use this. So there's going to be numbers here, and that's where the Pascal's triangle comes from. So we start with x to the 5th, so the first one to the highest power, which was 5, and then times 2 to the lowest power, which is 0. Then we add, leave a space. Now we decrease, so 5 now to 4, and then 2 up to 1. Again, decrease in the x, increase on the 2. Decrease, increase. And then you go all the way until you get to, I started decreasing. That's supposed to be 3. You get until you get to the highest power again. So blank, x to the 1, 2 to the 4th, plus now x to the 0 and 2 to the 5th. So the numbers that go on those spaces is based on your rows in Pascal's triangle. So we're in the 5th power, so we go to the row with 5 and enter each number. So 1, 5, 10, 10, 5, 1. So we got those numbers from here. Let me make that smaller. These numbers here are these numbers here in order. So now that we have it all written out, we're going to start simplifying and combining like terms if it ends up being that. So x to the 5th is just x to the 5th. 2 to the 0 is 1. So 1 times x to the 5th. So it's like 1 times x to the 5th times 2 to the 0, which is 1, plus x to the 4th is x to the 4th. And then 2 to the 1 is 2. So I'm going to put the numbers next to each other and keep x to the 4th. And then we have plus 2 squared is now 4. So 10 times 4 times x to the 3rd. 2 to the 3rd is 8. So 10 times 8 x squared. 2 to the 4th is 16. So we have 5 times 16x plus 2 to the 5th is 32. So 1 times 32 times x to the 0, which is just 1. Now let's simplify this. So 1 times 1 is 1, times x to the 5th is x to the 5th. 5 times 2 is 10, so 10x to the 4th. 4 times 10 is 40, so 40x cubed. 8 times 10 is 80, so plus 80x squared. And then 5 times 16, let me get a calculator, is 80. So plus 80x, and then plus 32. We have no like terms, so that's our answer. Okay, so let's try this again, but now we have 2y minus 3 to the 4th power. So let's start by, we have 2y to the 4th, and it's the whole thing. So even that 2 is going to get to the 4th. And then negative 3 to the 0. Because it's minus 3, that's why we're using negative 3. Okay, plus, space, 2y to the 3rd power times negative 3 now to the 1. Plus, space, 2y to the 2nd times negative 3 to the 2nd. Plus 2y to the 1 times negative 3 cubed plus space 2y to the 0 times negative 3 to the 4th. Okay, so let's add in those numbers from the Pascal's triangle. So we have it had a 4th exponent, so we're going to the row with 4 in it. And then we're going to add those in here in order. So we have 1, 4, 6, 4, 1. Now we're going to start simplifying each one. So 2y to the 4th is 16y to the 4th. So 1 times 16y to the 4th. And then negative 3 to the 0 is just 1. Plus that 4 times negative 3 to the 1 is negative 3. And then 2y cubed is 8y. And then plus 6, negative 3 squared is 9. Plus 4y. Oh, I forgot the squared and the cubed here. And then plus 4 times negative 27 times 2y plus 1. 2y to the 0 is just 1. So plus 1 times 1. And then negative 3 to the 4th power is 81. Now let's start simplifying some more. So this is 16y to the 4th. And then that would be minus 98y cubed. Then this would be plus 216y squared. And then minus 216y. And then plus 81. Okay. Next, we are going to find the coefficient of y to the 8th in the expansion of 2y plus 3 to the 10th power. So that means we are going to need to find that 10th row in Pascal's triangle. So we found the 6th one, so the next would be the 7th. So we have a 1 on the outside. 6 plus 1 is 7. 6 plus 15 is 21. 15 plus 20 is 35. So 35, and then 21, 7, 1. Now row 8, 1, 8, 28, 56, 70, And that was supposed to be 35. I switched that. 35. Okay, and then we have 56, 28, 8, and 1. Now the 9th row. 1, 9, 36, 84, 126, 126, 84, 36, 9, 1. Then lastly, the 10th row, 1, 10, 45, then 120, 210, 252, 210, 120, 45, 10, and 1. Okay, so we are only looking for the coefficient of the y to the 8th term. And the y is part of the first, so we're starting. This would be 2y to the 10th. With the 10th term, we would have 2y to the 9th. On the 45, we would have 2y to the 8th, because remember, you're decreasing as you go down. So we would have y to the 8th power at that 45. So we can skip ahead to having 45 as that coefficient, and then it would be 2y to the 8th, but don't forget that we have the plus 3. So we need to figure out what power would the 3 be. So it would start off being 3 to the 0 on the 10, 3 to the 1 on the, 3 to the 0 on the 1, 3 to the 1 on the 10, and then 3 squared on the 45. So add that squared in there. Now let's just simplify. So this ends up being, if we end up multiplying this out, 103,680 y to the 8th. But it just wants to know the coefficient, so the coefficient is 103,680. Alright, so for the last example, we are finding the 6th term in the expansion x plus 2 to the 9th power. We already have the 9th row from when we were expanding Pascal's triangle in the example above. So we need to figure out, okay, which one is the 6th term. So first I'm just going to write out that 9th row. So 1, 9, 36, 84, 126, 126, 84, 36, 9, and 1. So which one is the 6th term? So this is the 1st term, 2nd term, 3rd term, 4th term, 5th term, 6th term. So the 6th term has 126 in the space part. And then let's figure out what the xth power would be. So here's x to the 9th, x to the 8th, x to the 7th, x to the 6th, x to the 5th, x to the 4th. So we have x to the 4th power here. And then what about that 2? So now we're going to figure out what the 2 is going to be too. So if we start out 2 to the 0, 2 to the 1, 2 squared, 2 cubed, 2 to the 4th, 2 to the 5th. So our 2 is going to be to the 5th power. So if we do 2 to the 5th times 126, we will get that this is 4,032 x to the 4th. And that is the 6th term in that sequence. So you could have gone and you could have figured out the whole thing, or you just figure out that one term and by our eliminating and figuring out what the exponent would be for each part of the expansion. So if you have any questions, please let me know.